So here is the beauty of the property we learned yesterday. If you are solving, and I'm going to do the log approach and show you this. If you are solving an equation, an exponential equation, why is it an exponential equation? Because the variable's in the exponent. The trouble is, how do you get that variable all by itself if it's trapped in an exponent? Well, we have that awesome rule that if you have a log of something that has an exponent, you can bring the exponent out in front, right? So what you'll do is if two things are equal, then when you take the log of them, they'll still be equal. So you take the log of both sides. So now it's just become log of 4 to the x equals log of 8. And the beauty of this is I can take that x out in front now. So it's x times the log of 4 equals the log of 8. And now that it's not trapped in the exponent, I can get it all by itself. Divide both sides by log of 4. Log and 4 are inseparable. You can't just have a log floating by itself. You have to always be taking the log of something. So you can't just divide by 4 and leave the log stranded. Log of 4 is a unit. It's a number. It works as a unit. So I divide log 4 over, and my answer is, and you just type that into your calculator, log of 8. Light. Log of 8. Now, when you hit log, it opens its own set of parentheses. So I have to close that, so it just takes the log of 8 divided by, see when I hit log, opens a set of parentheses, divided by the log of 4, close parentheses, enter. 1.5 equals x. Now, 90% of the exponential equations in the world have to be done by taking the log of both sides. That will get your variable out of the exponent. I started with one that we also would have been able to solve the other day by the method of common bases, because 4 is the same thing as 2 squared, yes? 8 is the same thing as 2 to the third, so I can cross out my bases and 2x equals 3. Divide both sides by 2, and x equals 1.5. Different method, same answer. Of course, because there's only one solution. But these were all written nicely so that would happen. The reality is common basis is not often going to be possible. So we do it the log way. Okie doke? Okay. So, very simply, your exponential term is by itself, log both sides, so it's log of 5 to the x equals the log of 18. Oops, not log to the 18. Log of 18. I bring my variable out in front, so it's x times log 5 equals log 18, and I divide both sides by the log 5. So x equals log 18 divided by log 5. And a lot of times, your answer, your multiple choice answers, will be written in this form. Yes? They may not even be in decimal form, but of course you can just type it into your calculator. Log of 18 divided by log of 5, and you can get round your answers to the nearest hundredth, 1 point. Oh, this is a good question. What's the nearest hundredth? 80. Good? Jump down to the next section. What's different about these? It's not just x. So what? Still, we're going to take the log of both sides. Log of 6 to the x plus 3 equals log of 50. It's going to be a little bit more complicated, but you'll see why in a second. We're still going to bring our x plus 3 out in front, right? Bring your exponent out in front. It's just when your exponent is a binomial, what do you have to now insert? Parentheses. So x plus 3 times the log of 6 equals the log of 50. What should you do first to both sides to get the variable all by itself, Andrew? Still divide by the log of 6. So x plus 3 is going to be the log of 50 divided by the log of 6. And then, how do I get x all by itself, Cameron? Subtract, what's it? The 3 from both sides. Minus 3, minus 3. So x equals log 50 divided by log 6 minus a 3 afterwards. Log 50 divided by log 6. Take that answer, subtract 3, negative 0.82. I saw a hand, Isaiah. Okay. Let's do B. Log both sides. Can we do, I just like to do that so I don't have to rewrite it. Then I'm going to take my exponent, which is a binomial again,